Ryan Johnson, and I was a reporter for Group 4, and we did the bomb calorimeter experiment. And first, I want to talk to y'all about what a bomb calorimeter is, just in case y'all forgot. And I want to show y'all the apparatus and the two different fuel samples that we use. I'd like to talk through the procedure that we went through, and then show y'all the results for each fuel sample. So first, a bomb calorimeter is used to measure the heat from combustion in oxygen bomb, which is just a calorimeter. And they can be used to determine calories that are in food. If you ever look on the back of the food, they got the box, it tells you how many calories are in it. And then it can also be used to determine what fuels are safe in a vehicle, whether you use diesel or gas. And so this is what the apparatus looks like. On the right, that was the actual bomb canister. And if you see 1D, that was the crucible that we put the sample inside of. That's where it rested during the experiment. And 1F is the ignition wire. We connected the ignition wire to 2 electrodes to complete the circuit. And the ignition wire had to come in contact with the sample for this to work correctly. So then we put the whole canister inside of a bucket full of water, and then the water inside of the bucket is used to see what kind of temperature difference we got during the experiment. And number 6 is the thermocouple that we use to measure the heat. These are our 2 fuel samples. One on the left is a 0.99 gram sample of benzoic acid, and then on the right is the 0.84 gram sample of the Sourtex candy. So the procedure we use, first we cut a 10 centimeter piece of the ignition wire, and then we placed our 0.99 gram sample of benzoic acid into our crucible, and then we touched both ends of the ignition wire to the electrodes, and then bent it in the middle to make a point that touches the actual sample. And we put water inside of the bottom of the bomb. We tightened the lid, and then we started our purging process. We injected oxygen up to 30 ATM inside of the bomb and released the pressure to purge the air, and then we pressurized it again with pure oxygen, and we kept it at 30 ATM for the experiment. And then we placed the bomb into the bucket, and the bucket is inside of a bomb calorimeter jacket, which is used just to insulate the experiment from the outside, just so you can't get any air from insulation. So then we connected 2 cables to the top of the bomb, itself. That the cables went to the switch that you would hit to ignite the bomb. And then we started our data. We connected the drive belt to the stir motor. The stir motor just circulates the water just so you don't get stagnant temperatures throughout the water. And after we saw that the water temperature was steady, we hit the ignition button and ensured that the red light flashed. The red light means that it was a successful ignition. And then we sat there for 3 or 5 minutes collecting the data, and then watched until the temperature crested. And then we stopped our data log, and then we opened and disassembled the bomb and took out the remaining pieces of wire that we needed to calculate in the end of how many calories of the wire were burnt. And then we repeated this whole process for the 0.84 gram piece of sour jack candy. And here you can see the results from our benzoic acid. And like Megan said, this first little hump, that was just the time between our thermocouple was in the air, and then we put it in to the water before our experiment. And then the point of combustion was right at the bottom of that second hump. So as soon as we hit the button, the bomb went off, and then the temperature of the water inside of the bucket started to rise slowly. And as soon as we saw that it was equalized, we stopped our data, and that ended up being 33 minutes after we ignited the bomb, and the water temperature rose 2.35 degrees, and then we had 6 calories of ignition wire left. And the same thing with the sour jacks. We had that first initial hump, and then the second one, except this one took 4.5 minutes to get to equilibrium, and the water only rose 1.18 degrees, which is less than the benzoic acid, and we had less calories of the ignition wire burnt. So to find thermal capacity, which is the same thing as heat capacity, which is the amount of heat supplied to a mass in order to raise that mass 1 degree or 1 unit. And so thermal capacitance is mass times specific volume, and that is equal to heat over the change in, or heat energy over the change in temperature. So for the calorimeter, we first calculated the heat from the wire that we burnt, which ended up to 71 joules, and the heating value from the benzoic acid, which, like Megan said, we knew 26.38, and we multiplied it by the gram sample that we had, and it ended up being 26.1 kilojoules. So if we use our formula, you can come out to 11,136 for thermal capacitance of the calorimeter. And then next we went to our heating value for the sour jacks, since we know our thermal capacitance from the calorimeter. And we had 77.4 joules from the ignition wire. We added that with the heating value from the sour jacks, which was 13,141, and the heating value for the sour jacks can end up being 15,552. That's it. Any questions?
Questions? Anybody? So that on the last slide with the heating volume of the ignition wire, that 2.3 calories per centimeter, is that a known value?
Yes, that's on the card that we had.
Okay.
For the ignition wire. It tells you the conversion for that.
Gotcha.
So if we had 2.3 calories per centimeter and we cut a 10 centimeter wire, that's 23 calories.
Gotcha. Thank you.